Hey guys, how's it going? Should I fix my light here? Okay, I'm going to show you something that's out of this world. I've been reading a lot about dielectric and electrostatic induction, and I've got these transformers here, 3,500 volts each. They're hooked in parallel on the primary, and the output of the secondary, the outer legs are jumped together in the center, and then the inner two are my output. Now, be that as it may, I'm not sure it has much significance here, just to get some higher voltage. So anyway, a little bit about what's going on here. The output of that is going into the bottom output of that is going straight to the earth rod outside the garage there. That's that wire down there on the floor, running along over there to the garage, to the ground rod. The other one's coming out. It's going to this spark gap, which isn't being used at the moment. And then over there, that little metal tab sticking out, and this one here. These are two separate plate capacitors that I made with some plastic and a sheet of aluminum siding kind of material in the center. I'll show them to you after a bit. But they're laying right next to each other, so there's like two pieces of plastic in between, in the center, and then two pieces of metal, and then outer pieces of plastic on it. Anyway, this big guy here is in parallel because it's adding some effect there. Additional capacitance is definitely helping with this effect. From there, this one leg of the capacitor, or the plate capacitor, which is also the output of this big guy, so essentially he's in series now, because the only actual voltage output we have here is from that other leg, that yellow and white wire you see back there. Yellow goes to the spark gap, white comes around here to the bottom plate capacitor, and also to the outer hull of this big guy here. So this guy is essentially in series in sort of a hairpin configuration. The output, the center electrode up there is coming around, going to the other side of the plate capacitor, and then to the spark gap. Now notice the spark gap is quenched, it's open far enough to where it's not firing. From this same terminal here, we go up into this coil that I wrapped. I got this jar at Dollar Tree, and it had these nice little ribs down the side of it. I don't know if you can make them out, but it worked perfect for holding a piece of this 16 gauge wire to run around there, or 18 gauge wire, sorry. So I've got like about 12, 13 wraps on it. It's about 5 inches diameter. Anyway, so the through this capacitor in series to that one in parallel, through the coil, the output of this coil is now going down inside the jar there to the bottom of this secondary coil, and then we have a top load and just that sitting up there for now. Over here, we've got a much larger top load dome, a 12-inch dome. Coming off of it is the wire going to the bottom of this coil here. Output of that is going through another condenser that I made just out of a little candle jar into the center of it, and then the outer aluminum foil on there is coming over here, just going to this fluorescent bulb. Now, it's turned on. You can see, you can hear it humming. I'm going to come over here, and I'm going to first turn out the light and show you what happens when I touch this bulb. So there's no real oscillations going on in this circuit because the spark gap's not firing. The other leg of the transformer series is going straight to ground. But what we have is a little bit of plasma coming out of this bulb that I'm pretty sure you can't make out because it's tiny. So you can tell there's not a lot of output coming out of there in the form of plasma. But the light bulb itself will slightly flicker when I hold it next to it. However, there's a weird dielectric antenna-like effect radiating from it. want to show you this first, and I'll take it apart and show you the rest. So, this bulb over here, I'm going to turn the light off, and I'm just going to touch this bulb. As you can see, it's lighting up. The camera's not picking it up so well. It's, you know, it's not great, but there's something going on here. Why this bulb's lighting up. Now, we're really inducting across this approximate 2-foot gap between the small dome and the big dome through all that coil and blah blah series capacitor. Just do an open end on the other side of the bulb. Well, some other weird things are happening. This block of wood, which is just a scrap from a 2x4, actually made a track to sit for those plates to sit into it, so that I've got 2 of them, I got another one over there, so I can spread them apart. The weird thing happens is when I set this on here, I put my fingers up real close to it, there's a parasitic effect and a significant vibration, well, a moderate vibration that is coming off of it, less than, you know, 1/8 of an inch away from it. I could feel it vibrating in my fingers. Same thing is true for this light bulb. I could feel it vibrating slightly. When I hold that light bulb up close within a few inches of this dome, very, very strong vibrations going on. There's definitely some electrostatic fluctuation, whether it's attraction and repulsion, or not quite sure what yet, going on here. And somehow it's inducing that dome over there and transferring into this makeshift circuit over here. Now the weirdest thing, part of the whole circuit is, and I know it'll happen if I touch that bulb, it's extremely strong, but over here I've got this other wooden block that's sitting here on top of this thing here. Now this is all plastic. This block, when I get close to it, it is extremely vibratory to the point where you can feel. Can you hear that? You can almost hear this really, really strong compressional waves vibrating my fingertips. I'm going to turn the light off and see if we can see anything actually happening. Oh, yep, you see the spark there? Camera's picking it up. There's electricity. It's not happening. Oh. There is, try to describe this in the dark, my fingertips are glowing purple from the field that's coming off of them. There it is. See, you turn the light on? That's my finger there, this back finger, and this is the field coming off of it. Off of this piece of wood. Now, I think this must be some kind of treated lumber, I think, because it was made for outdoor. So I don't know if that's a surface conductive coating or sealer or what, but this is plastic, so this is insulative, even though there's massive amounts of charge inside of it. Must have some effect on it. But look at what's happening on the thing here. You see all those, I'm holding this with my hand, and all this dust and dirt particles are being attracted to it. And they fall off when I get too far away. But, so it's definitely coming through, it's coming out of this lid, and it's transferring through the wood to the point where it's really vibrating the crap out of my fingers. Now, this seems to happen with almost anything I stick on here. So I'm going to take a piece of electrical tape and put it down there and put my finger on it. Hold on.